Okay. So let's start the today class. Today we are going to discuss the equivalent circuit of the transformer. Okay. In the previous class, we already explained their equation. That means core loss of the transformer, their magnetizing and core loss resistance. How we can just find out. That means RC and XM. Okay. So just share the screen. Okay. So this is the equation for the equivalent resistance referred to the primary side or secondary side or maybe leakage reactance referred to the primary side and secondary side. Okay. So when the leakage reactance drop refer to the primary side, that means I1 dash I1 X2 dash. Okay. X2 dash is your equivalent leakage reactance referred to the primary side and X2 is your leakage reactance of the secondary side. So total equivalent leakage reactance of the secondary side, that means primary side, that is represented by Xe1 and secondary side represented by Xe2. So Xe1 is equal to nothing but the primary side leakage reactance plus secondary side leakage reactance referred to the primary side. That means X2 dash. Okay, X1 plus X2 dash. So that is X1 plus X2 dash. And in this primary side leakage reactance referred to the secondary side. So summation of the secondary side leakage reactance, that means X2 plus X1 referred to the secondary side, that is nothing but X1 into M2 by N1 whole square, that is represented by X1 dash. X1 prime or X2 prime is denotation for the leakage reactance referred to the primary side and secondary side and primary side respectively. Yeah. So this dash you have to keep in your mind. That is refer secondary side reactance towards the primary side, and this one is your primary side leakage reactance refer to the secondary side. Okay. So similarly, we can represent in the total equivalent leakage impedance of the primary side refer to the primary side. That means R equivalent, this quantity R equivalent total resistance referred in the primary side plus total equivalent leakage reactance referred to the primary side. Okay, so impedance equal to nothing but R equivalent 1 plus JXE1. And similarly for the leakage impedance referred to the secondary side, that is represented by X RE2 plus JXE2. That means total equivalent resistance in the secondary side plus total equivalent leakage reactance in the secondary side. Okay, so this is the representation of the impedance, leakage impedance of the primary side and secondary side. So just try to draw this circuit, how we can just connect their diagram. So equivalent circuit, yeah. So this is the equivalent representation of the transformer when exciting current is neglected. Okay. When the exciting current is neglected. So parameters you have to all represent here. That means V1 is your supply voltage and R1 and X1 is your primary side resistance and leakage reactance. And current flowing, that component is I1 the primary side come from the source, and this is your secondary side terminal voltage V2, and the resistance and reactance of the secondary side represented by R2 and X2. This is your the transformer. Okay. In this case, we have just represent the E2 is secondary side EMF induced, and this one is your EMF induced that is equal to V1 dash or maybe E1, that is E1. Okay. So when the exciting current neglected, but when the exciting current we consider, then this is the exact equivalent circuit of the transformer. Okay. That means I1 consists of two components. One is your I1 dash, that is contacts the load current I2, that is nothing but I2 N2 equal to I1 N1. Okay, if exciting current neglected, so this one is your secondary side component current that is equivalent to refer to the primary side, and this is your whatever the current drawn in the secondary side or drawn to the load, so that is represented by I1 dash, and this is your exciting current or no load current that is represented by IC, and in the shunt branch, that means the core loss component resistance RC and XM are in parallel. So this RC is responsible for the core loss of the resistance, and XM is known as the magnetizing reactance of the primary coil. Okay, so this is represented by nothing but V1 dash, that is equal to V1 EMF induced in the primary coil, and all component you have to familiar, and this one is your ideal transformation denotation with the all parameters primary side and secondary side. So this is all about the primary side parameters, and this is all about the secondary side parameters. Okay, so 1 and 2 just refer for the LV or HV winding, or maybe primary or secondary winding. Okay, after the connection of the transformer, maybe say that the primary and secondary. Okay, so this is the equivalent, exact equivalent circuit. If we want to transfer these parameters towards the primary side, then how we can draw? Their mathematical transformation we already tried few minutes earlier. How we can represent the R2 and X2 refer to the primary side. So that just you have to connect to that one, nothing more than that. Okay, so and V2 and I2, how we can equivalent to the primary side. Okay, so when the secondary side parameters, that means resistance, reactance, and voltage transfer to the primary side. So just simply equivalent leakage reactance of the secondary side, just represented by X2 dash and refer to the primary side. You know that what is the value of X2 dash in terms of X2, that is nothing but X2 into N1 by N2 whole square, and similarly R2 dash is nothing but R2, that is secondary side resistance, into N1 by N2 whole square. Okay, so this derivation we already seen in few minutes earlier. So and this is your I1 I2 and transfer refer to the primary side, that is represented by I1 dash is nothing but I2 into that reversely proportional to the turns ratio, that means N2 by N1, and voltage if you transfer, that means directly to the turns ratio, that means this one will be represented as V2 dash when we transfer towards the primary side. So this one V2 dash is nothing but V2 into N1 by N2. So this is the equivalent circuit when referred to the primary side. Okay, and these parameters is already shown here. So this one is same, nothing more than that. So R1 and X1 is the primary resistance and reactance, leakage reactance. Okay. When if you want to primary side parameters transfer to the towards the secondary side. Okay. So how we can that represent that is? That means all the parameters, that will V1, I1, and RCXM refer to the secondary side, and this R1, X1 refer to the secondary side. Okay. So their derivation R1 when refer to the secondary side, that is nothing but represented by R1 dash, that is equal to R1 into N1 by N2 whole square, and X1 dash equal to X1 into N1 by N2 whole square. Okay. And similarly for this resistance and reactance also, that means core component of the and magnetizing reactance, that is XM. Okay. So RC equal to maybe represented as RC dash equal to RC into N1 by N2 whole square. Then you refer towards the secondary side, and this is the ideal transformer connection. So just when we refer towards the secondary side, so that circuit may be look like this one. Okay, that means look like in this manner. Okay, that means when referred towards the primary secondary side. means this parameter is same, that means R2 and X2 of the secondary side resistance and reactance, and this is your secondary terminal voltage V2, and this is your EMF induced of the secondary winding E2, and this is current flow from this side to the load is I2. Okay, now we denote the primary side parameters refer to the secondary side. So R1 is equivalent to R1 dash towards the secondary side, and X1 is X1 dash, and I1 is your N1 by N2, and V1 is your N2 by N1. That means directly proportional. Okay, so V1 into secondary side turns ratio divided by primary side turns ratio. And this one is your V1 dash. Okay. That is nothing but N2 by N1. So this is the circuit representation of the either side, maybe primary side or secondary side referred. Okay. So if you want to more simplify, that means simplification of the circuit, then we can just simply draw this the uh, general representation of the transformer, that is this one. Okay. So here in the that is R1 and X1 and V1 and RC and XM. So this parameter is transferred towards the primary side, either maybe. So prime of that means X2 dash and R2 dash we may be omit for the convention. Okay, and this is your V2 V2. So this circuit may be more simplified, so just like as a this exciting shunt branch, that means exciting current flowing through the RC and XM, that is IC and IM. Okay, core loss current and magnetizing current. Okay, this may be taken as towards the side of this resistance, that means primary side decrease impedance, or maybe taken from outside of the secondary side. So if we draw their simplified diagram, then it will be just look like in this way. Okay, so this shunt branch may be referred to either this side or this side. So what will be difference? Something like that. That means I exciting current, if we this shunt branch is placed at this point, suppose that behind the primary leakage impedance, that means R1 and X1, then exciting current do not flow through this primary side leakage impedance, that means R1 and X1, since this shunt branch is placed here. Okay, so this drop may be not considered. But if the shunt branch placed outside this secondary side, then the primary side leakage impedance drop, I exciting current, we have to consider. Okay, so actually no load current is very small in the transformer. That means only 2 to 6% of the rated current. Okay, so that voltage either may be neglected of the shunt branch across the shunt branch, or maybe consider. That doesn't matter, but our calculation is very simple. If we simplify the circuit, either this side or this side. Okay, so if we simplify it, or then we can just place here the shunt branch, then this impedance and this impedance are in series, is it not? If the shunt branch is placed this behind the primary leakage impedance, that means R1 and X1, then this R1 and this R2 are in series. So we can calculate the equivalent resistance, and this X1 and this X2 in series. Either if you place this shunt branch here, or maybe this shunt branch place here. Okay. So equivalent resistance can be represented R1 plus R2 dash and X1 plus X2 dash. Okay. So their circuit just look like this way. Yeah. So this is this circuit. place here. That means either put here or put here. So exact equivalent circuit may be shown here. If the shunt branch place here behind the primary leakage impedance. Okay, so this one may be drawn just like this. Okay. And the shunt branch behind primary leakage impedance top. So total resistance, equivalent resistance equal to R1 plus R2 plus maybe dependent here I2 R2 dash. So and X equivalent equal to X1 plus X2, or maybe this shunt branch place here, that means the outside of the secondary side referred resistance towards the primary. So total resistance and leakage reactance again, that means R1 plus R2 dash, that is R equivalent, and X equivalent is your X1 plus X2 dash. Okay. Maybe shunt branch, as we know that the shunt branch may be neglected. If we neglect the shunt branch, that means this branch. If we neglect it, okay, then we can just simply got this circuit. If we again draw, that means R equivalent and X equivalent, and this is your V1 and V2. Okay. So this is the simplified forms of the approximate equivalent circuit. Okay, A and B. This one is your approximate equivalent circuit. Transfer either the shunt branch here or shunt branch here. And if again we simplify, that means the RC and XM is to move to the primary side in a, so still further simplification, that means RC and XM, that this lead to the equivalent circuit of frequency. This simplification is nearest to neglecting the exciting current IE in comparison with the rated current. So this branch is for exciting current or no load current. So compared to the rated current of the transformer, this current is very small. That means 2 to 6%. So that in a transformer I have the rated current 100 ampere. Okay, then their no load current value is only 2 to 6 ampere, 2 to 5 ampere. So that no load current may be neglected compared to the rated current of the transformer. So if we neglected this branch, then we just simplified circuit in this form. That means only remaining part is R equivalent and X equivalent. Okay, R equivalent and X equivalent. So quite a small. The equivalent resistance RE in the next part is just that means after the simplification of the circuit, either this one or this one, their efficient branch or neglected or no load current is very small compared to the rated current. So we can just neglect the comparison to the rated current. Okay. So circuit will be simplified something like this one. Again, if you observe that the equivalent resistance is very small compared to the leakage reactance. So again, we can simplify this circuit just like as neglected to the equivalent resistance compared to the equivalent leakage reactance. Okay, so if resistance neglected, then just again draw the circuit, so becomes look like this one. That means only the equivalent leakage reactance of the transformer, that is X1 plus X2 dash, nothing but, and I1 equal to I2 is here. This is your primary voltage of the transformer, that means P1, and this is your secondary terminal voltage referred to the primary side. Okay, so similarly, this is the simplified form of the transformer. So either maybe parameters refer to the primary side or secondary side, okay, of the transformer, and we can easily calculate any other parameters of the transformer and analyze the transformer performance. So this is all about the equivalent circuit of the transformer. Okay, all the parameters denote on the circuit and how they can relate their voltage equation of the primary and secondary. So simply we can write here V1 equal to I1 or I2 into X1 X2, that is X equivalent equal to V2. Okay, now if you apply this network theory in this circuit, then how we can write for the V1 equal to how much? V1 equal to nothing but I1 into x1 plus x2. Okay, this part. Or V1 minus V2. Suppose that this is your V1 and this is your V2. So V1 minus V2 equal to I1 into x1 plus x2, or simply you may be right here I1 into xe. Okay, so V1 minus V2 equal to xe. This is a very simplified circuit of the transformer. Okay, so we stop here, and in the next class we will discuss uh, another things of the transformer. Okay, so just we stop here.